Hey everyone, Lee Archinal here with another happy hunting session. Today, we're diving into PsExec, a tool that is often used in IT operations, but often and heavily abused by adversaries like Berserk Bear. I'll walk you through how threat actors leverage PsExec or PsExec-like tools, the traces it leaves behind, and how we can use proactive threat hunting to find the evidence. All right, let's get into it. Using the Russian APT tool matrix, we can follow Berserk Bear's tracks. See what I did there? But specifically, when focusing on the use of PsExec or PsExec-esque type tools. While the legitimate version of PsExec is used in attacks, there's also two other popular tools that have PsExec-like tools or modules or capabilities, and these tools are Impacket, and Metasploit. Both these tools have many more capabilities than just running their version of PsExec, but the goal remains the same with the PsExec module. But why is PsExec such a popular tool to abuse? Well, one thing, and this is from the Rapid7 Metasploit framework GitHub, so the people that can really update Metasploit, one thing that PsExec is used for is to demonstrate how stolen passwords could lead to a complete compromise of an entire corporate network. It has the ability to remotely create accounts, execute code, leverage Windows services to escalate privileges from admin to system level with a single argument, which is a -s, download or upload files of the network, and more. It truly is a tool with great capabilities that are unfortunately abused by adversaries. Now that we are familiar with some of the capabilities, we need to know about the artifacts these tools leave behind. When either of these are executed, they install a service on the remote or victim machine that usually has a funky looking name executable. If we look at the Metasploit documentation, coming down here, we can see that it's uploading the payload, it's created this randomly named executable, and then the service started successfully, then it deleted itself. But what we see here is that not only was this executable dropped and created on the machine, but then it was run. Now, knowing about this or thinking about the child process and the parent process relationship, normally when a service is started and it runs an executable, services.exe is going to be the parent process. But let's take a look at another article that we're looking at to gather some more information. So if we come to another article that covers detecting impackets in Metasploit's PsExec, it's in the name. If we come down to the detection section and select 4697 and 7045 event logs, it'll take us to the logs that we can find during the investigation. So first, it says the event 4697, or a service was installed on the system, and we can take a look at the service name, which is this randomly named lowercase x HDI, and we see the service file name. It looks just like what we saw in the Metasploit documentation. It's a randomly named executable. And as we scroll down, we come down to the event 7045, which is another log that is captured whenever a service was installed in the system. And it captures similar artifacts. Now, if we scroll down to the Metasploit section, we should see similar activity. We see event 4697, a service was installed in the system. We see service file name, another randomly named executable, and then so on. So we see the same type of behaviors from both tools, and those are the things that we're going to pivot off of. Now that we got our artifacts and our thoughts in line, let's build on that hypothesis. Let's look for these randomly named executables being created, and then let's look for the parent process being services. So let's enter the Intel 471 Hunter platform and see what we got. So here we are in the Hunter 471 platform, and we're looking for our Metasploit, Impacket, PsExec process creation activity hunt package. Fortunately, or unfortunately, however you take it, this type of behavior was recently seen with the Fog ransomware, which is an emerging threat that we built a collection around. But I digress. Or if we think about it, that article that led us from 2021 to look for some evidence now stands true. I would like an indicator of compromise or a file hash or a file name to see if it has the longevity of an artifact like that or a behavior like that. Normally they don't. IOCs are normally burnt, once the hash is found and known as malicious, it's done for, and the adversary can't use it anymore. But behaviors, those are effective much, much longer. So let's jump in. So we've got the Metasploit, Impacket, PsExec process creation activity. We scroll down to the description. We're looking to detect process creation containing names consistent with the schema used by Metasploit or Impacket's PsExec tool. How are we doing that? We scroll down to the query logic table, which is here, and we look at the field value relationship. We're looking in the parent process path field, or whatever the parent process is, and we see we're looking for services.exe. Also, looking at the process path or the child process, and we can see that it's this REN. We're looking for a combination of lowercase and uppercase letters, specifically 8 of them, and a .exe. Now, we're looking for this relationship and looking at a 4688 or really a process create style activity. So it doesn't have to be 4688. It could be whatever tool or event type or event name that your tool is using. Could be event simple name, could be event code, could be event ID, you name it. But we're looking for that process create mentality. So let's scroll up. Let's grab our Splunk query because that's the tool we'll be using. And of course, as always, I'm going to be using the sysmon log source. But let's get into the tool and see what we can find. So we ran the query. Once again, looking in the index sysmon or the log source being sysmon. We're looking for the parent image or the parent process being services.exe. So we used regular expression or the transform in Splunk to look for the combination of a lowercase or uppercase alphabetical characters being 8 in length and ending in .exe. And then we aggregated the data to make it look better. But what we see, and what we always want to do first, is confirm. So if we take a look at the child process path, we see that there are 1, 2, 3, 4, 5, 6, 7, 8 letters in that executable name. So we see C Windows ABCDEFGH.exe, but also the parent process is services.exe. So this matches the logic, which would appear to match the intent of this executable. And now the question is, where are we going to go with this? Well, we could go multiple places. We could go back and look for a 4697 event code that we discussed earlier. We can look for event code 7045 that captures this behavior too. The goal there would be to see when that service was installed and be able to confirm that. Or we could follow this ABCDEFGH.exe and see what it did. So set that as the parent process and see what child processes it spawned. Were there any network connections? Did it modify any registry keys? Did it create any files? And so on. There's so many things you can do with this one artifact, but it's up to you to figure out where you're going to go with that investigation. With today's session, we've seen how PsExec and PsExec-like tools leave critical traces that, if you find them, can make all the difference in a successful hunt. Using the HUNTER471 platform and resources like the Metasploit, Impacket, PsExec process creation activity hunt package, you'll have the tools to track patterns used by adversaries like Berserk Bear. For those wanting to explore further, please feel free to get your community account on HUNTER471 using the link below to access a comprehensive library of advanced threat hunting packages, detailed analyst notes, and proactive recommendations. These resources are designed to strengthen your threat hunting capabilities and keep your organization secure. Thanks for joining. Stay tuned for the next one. And as always, happy hunting.